Hey, good afternoon, everybody. My name is, I don't know if you guys can hear me. So, my name is Oshioke Salaki, and I am the instructor for the Frontend development section of the Cairo Bootcamp. So, today this section is going to be done in two parts. We have the presentation slides where I'm going to explain key concepts in Frontend developments for Web3 and Starknet developments. So, let's go through the slides. In this presentation, we're going to be talking about the tools required for front-end development, which are Starknet.js, Starknet Kit, NPM, Node.js, and we're going to talk about an introduction to Starknet.js, along with its components, ABI, and also getstarknet. So, what is Starknet.js? Starknet.js is a library that helps to connect your website to your decentralized application, otherwise known as dapp, to the blockchain-based Starknet network using JavaScript or TypeScript language. The Starknet.js components, we have the provider, designer, account, and contract. And we can see a small diagram there showing how everything is linked together. So we start off with the provider. The provider is an API from Starknet.js that enables you to interact with Starknet without necessarily signing messages, e.g., when performing read calls. You can read states without signing messages, but you cannot alter or modify the contract state. So the provider acts as an interface for us to read states. You know how state is stored in the storage of a smart contract, a Starknet smart contract. So with a provider, we can use it to perform read calls without necessarily connecting our wallets to the dapp. That's what the provider does. But you cannot use the provider to perform write operations. Write operations are operations that change the contract state. So we have the signer. The signer API allows you to sign transactions and messages. So the signer is what enables you to change the contract state. It helps you to sign messages. That's when you go to dapps and you click a button, you see how your wallet pops up. So your wallets are regarded as your signers in front-end development. Then we also have accounts. The account API extends to the primary features of the provider API to also include the signer API, which can be used to create and verify signatures. This API, unlike the provider, can make both read and write calls to the blockchain, and as such is the primary way to interact with Starknet contracts. So with these accounts, unlike the provider, we can use it to perform both read and write operations in our contracts. So we have contracts. Contracts are primarily how we create instantiations of our smart contract with JavaScript. It takes the contract ABI, that's the contract address, and the provider or accounts, depending on what operation we are trying to perform. If we are trying to perform only a read operation, it will take the ABI, contract address, and provider. When we are trying to perform a write operation, it takes the ABI, contract address, and account instead. So what is an ABI? An ABI is the application binary interface. It's a JSON representation of a deployed smart contract, which exposes an interface which other smart contracts can call functions within the smart contract. The ABI generally is found on block explorers such as Voyager or StackScan, and I'll be showing you how to get an ABI later on. So getstarknet is another tool that we use in front-end development for Starknet. So getstarknet is a development SDK which enables developers to effortlessly build and connect their dapp to Starknet with Starknet.js. It is open source and easy to implement. That's one reason why it's very popular and recommended to use. So before we get into the coding session, I don't know if anyone has any question, or if you're a bit lost, it will be clear when we start the coding session. So I don't know if there's any question. So I guess there's no question. So let's jump right into the coding section. So first of all, so for today's lecture, we're going to be implementing a counter dapp. So for this counter dapp, we already have a counter contract. Basically, how the contract works is that it has one read function and one write function. So for the read function gets the counts. Then it has another write function that is to increase the counts by 1. So those are the two functions that we have. And you can view the contract on StackScan with the address, with this particular address. So I'll be pasting the link on the chat so everybody can check it out on StackScan. So that is the link to the contract on StackScan. So when coming to StackScan, we are greeted with this interface first of all. Here we can go directly to the class code or history where we can see ABI here. So this is where we can get the application binary interface. So you can see, as we said, it's an interface that provides an interface so that other smart contracts or dapps can call the functions within it. So you can see how it is structured. You can see all the functions along with the arguments, if any, and the type of function, whether it's an external function or a view function, and the type it also returns or the inputs needed for it. So that's how you can get the ABI. So along with that, you can also perform read and write operations directly on StackScan, where if you come to this read and write contract segments, you can toggle between the read and write function because they are clearly divided. So you can see in the read function, we have this function called getBalance. And if we open it, we can see how we can query it. I'll show you guys something very soon. So when we query this getBalance, we can see that the balance is zero. That's how we can get the outputs. But if you go to this write function, you notice that we have this connect wallet button. Remember what I said that with read functions, you only need the provider. But for write functions, you need an account to perform. Yeah. And an account is coupled together with the signer. And the signer, as we said, is a wallet address or our wallet. So if we connect our wallet here, we can connect to either Argent or Bravos. So in Argent, you see that it's connected. That's the only time that we can increase this balance, and we can increase it by a particular value here. So you can see that it prompts us here to our wallet. So this is our signer. This is where we can sign and verify the transaction, right? So if we confirm this, you can see that the transaction outputs a transaction hash for us. So if we go back to our read, function, we are supposed to have an update on the balance. So if we query it, we can see that it has been updated to 1. So that's how both read and write functions work. So now we need for us, because we need a user-friendlier approach in case we want to create an application where the general public, can be able to interact with our contract with a front-end interface, maybe on the web or mobile. So that's what we are going to do today. And for this application, we are going to be making use of React.js, which is a popular JavaScript framework to use. So I already have a boilerplate for us. So this is just a simple counter dapp that I built up. The UI isn't really that fancy, but we are going to implement the core functionality, such as getting the count and increasing the count. So that's what we are going to do today. So let me just take you through the file structure a bit. So right out of the box, when instantiating a new React project, we have these default files, the node modules, the public folder. We'll not really be doing anything in the public folder. We have the SRC folder. So ideally, when creating a dapp, we need a folder called ABIs. This is where we are going to be storing all our ABIs, because there are sometimes where we might have an application that makes use of more than one ABI. Then we have our assets for pictures or images. Then the components. React makes use of a component-based structure where we can arrange our application in the form of components that we can easily reuse in different parts of the application and stack it on top of each other to form the whole application all together. So for components, we just have one component, which is the navbar. Then we have our CSS file. Then the main file we are going to be working on is the app.js file. So on top here, we have some imports that we are going to be making use of. So we are making use of getstarknet, but we're making use of the getstarknet by Argent, because Argent allows us to make use of web wallets apart from the normal. You want me to zoom in? Okay. So apart from the normal Bravos and Argent wallets, we can make use of web wallets with Argent getstarknet. And we also have, yes, the browser extension. Then we also have some hooks that we make use of, such as use states, use effects. Then we have we have some variables that we're going to be making use of from Starknet, which is the contract, RPC provider, constants. Then this is where we're importing the ABI, then the components and some pictures that we'll be using. We are not really using any pictures, so I can clear that out for us. So, okay. So then we now have our main app component here. Okay, let me zoom in. So we have our main app components. So in these app components, we have some state variables. So first of all, we first have our contract address. This is the contract that has been deployed and we viewed earlier on StackScan. This is the contract address because we'll be using it for, remember we are going to use it to instantiate a new contract, as I mentioned earlier. Then we have some state variables here, such as the connection, the account, and the address. Then we have a state variable for the count, when we are receiving the count and when we want to update the count. So then we have some functions here these are the functions that we're going to be using. We're going to be using the connect wallet function, disconnect wallet, increase counter, and decrease counter. Then we also have the get counter function here. And you notice that they are all marked as async. Async means that it's because we are going to be fetching data from the API. That is why we are using async, because we are going to be awaiting results. So then we have the component structure. This structure is what is outputted to the screen here for us. So the first thing we're going to be doing is connecting our wallet. So connecting our wallet, because every dapp needs a wallet to be connected in order for the wallet to be able to sign transactions and so on. So what we are going to be doing is that right now our connect wallet button is not really functional. So we are going to be making that very functional right now. So in this connect wallet function, the first thing we are going to be doing is that we're going to be making use of the connect function by Argent getstarknet. So we are going to be awaiting it because we are fetching a result. So we are going to await connect here like this. And so for Argent getstarknet, it takes in an object which is the web wallet URL like this. Okay. It takes in the web wallet URL. So we can just get this here. So we have https web.argent.xyz. This is the web wallet address. And this returns a variable, an object called connection, which you can name connection. So let connection be equal to await connect. We now set the web wallet URL to this link. Then once we click on this, that means this is what brings out that modal for us to choose the wallet address that we are going to be connecting to. So the next thing we are going to do is that we are going to now set our states. So we are going to first of all we have to have a conditioner here to make sure that we actually have a connection, and connection.isConnected is true. So there's a variable called isConnected, which is a boolean. So we have to put this check to make sure that the connection actually went through before setting any states. So the first state we're going to set is the connection. So we are saying set connection to connection. Then we're going to set the accounts. So we set accounts to connection.accounts. Then we set the address to connection.address like this. So just for us to see it, I'm going to be console.logging all these values so that we can take a deeper look at it and see what actually comes out. So I'm going to console.log connection here. So we already put it in a way that once we connect our wallet, I'm coming 71, okay. I'm coming. Some images are missing. Minor. Eh? Set connection. Set connection is the state changing function that we have that's being returned when we So just give me a minute. Access minus icon add import. Okay, so now if you click on connect wallet, you see, so we're having an error. Fail to fetch. So it's probably a network issue. Okay, it's like it's already connected. Let me try and do something quickly. Connected times. Okay. So I've connected to it before. Okay, so once we click, okay. So once we click on connect wallet, you see that this modal is supposed to pop up. Can you see it? Can you see it? Can you see it? So when you click on connect wallet, you are greeted with this modal where you're able to choose either between connecting to a web wallet, a Bravos account, a Bravos wallet, or an Argent wallet. So for this, I'm going to be connecting to my Argent wallet. So if I click this, you input your password and connect. So let me try and I'm coming. So we can output this our wallet address. Okay. So in our console, we can now see the connection that has been made. So if we see this connection object here, and if you view it, you can see the accounts that we extracted. We can see the chain ID, which is on Sepolia. We can see the icon, is connected, is pre-authorized. We can see the address and so on. Okay, it's actually, so they don't make use of address, they make use of selected address. So we can change that here. So it's connection.selected address here. So okay, so yeah, so that was the error. So I did the UI in such a way that once you connect, your wallet address is being outputted here along with a disconnect button. So now we can see that our dapp is officially connected to our wallet address. So, and you can see the address here is the same thing. It's the same thing here. So that's how you know that everything is working well in the Connect wallet. Do you have a question? Is there any question?
So the select address. Is it your wallet address?
Yeah. Is the wallet address connected to the dapp? Yes. So the next thing we're going to. Okay.
So those you know me, I'm not React so set address are functions.
Yes, they are state changing functions.
Because when you pass use state into when you destructure use state,
Yeah.
you get a function.
You get the current state value and the state changing function with it. So
Beside this
yeah,
use state function,
yeah.
it becomes the connection value and the set connection.
Where is that? This one, which one are you talking about? Yeah, it's just for state management. So use state is a React hook. It's a React hook. So and that hook, when calling that hook, it returns two things which you destructure. This is called destructuring. So and the first element of that destructuring is the current state value, and this one is the state changing function of that value, like a setter. So that's how use state works. Does anybody have any question? Again. So
I want
oh,
a UI to connect the wallets.
mm,
Do we do that also?
yeah, yes, but it will be shared later. It will be shared later in the class. So is there any other question? So if there's no question, then we can go to the disconnect wallet. So the disconnect wallet is quite easier. So what we are going to be doing, we're not returning anything. So we are going to await. We have a function from getstarknet called disconnect. So it's just as easy as awaiting disconnect. Then we just call the function. Then after disconnecting, we are now going to reset all our state changing. We're going to reset all our states. This connection is supposed to be null here. Account is also supposed to be null, and address is supposed to be like this. So this is the initial state. Initially, we don't have any connection. Initially, we don't have any account, and initially our address is an empty string. So after disconnecting, we are going to now set our account to undefined. We are going to set our connection to undefined, and we are going to set our address to an empty string like this. So this is all for disconnecting your wallet address. So if we now go back and try it, okay, let's connect it. After connecting, if we now disconnect, okay, so internet related. So if you disconnect, okay, this like okay. So the issue is from here. The on-click is supposed to be disconnect wallet. So if we disconnect wallet here, so just is not a function. So we have the slide bug 39. Okay, it's set address. Okay, so after clearing all our bugs, if we click on disconnect, you see that our state has been reset and we are back to this connect wallet. So if we connect wallet, we are connected to the Argent, to my Argent wallet, and we can see our address and the disconnect wallet button. Then if we click disconnect, everything in this function is being done. We are disconnecting with this function from getstarknet. Then we are resetting all our state variables here. So that's basically how disconnect works. So the next thing we are going to be making use of is the get counter. So, okay, so I'm calling it in my navbar. So I have this button here. So the navbar is set in such a way that whenever there's an address, the connect wallet button is being showed. But whenever there's no address, whenever there's no address, the connect wallet button is shown. But when there's an address, the wallet button is being shown. So that's what is being done in the navbar component. So back to here. Now we're going to be doing our get counter function first. So for this get counter function, the three things that we need. We first need our ABI, then we need the provider, then we also need, since get counter is a read function, we only need the provider, the contract address, and the ABI. Those are the three things that we need. So first of all, let's get the ABI. So as I showed you guys, the ABI is here. So we can just copy the ABI code here. Then as I said, in your source folder, you create an ABIs folder. Inside the ABIs folder, you can create an ABI.json. Then you can paste in the ABI here directly. So you save that and you now import it at the top level, at your top level code right here. So import contract ABI from, you now put the path to the ABI here, and it's automatically available to you in this variable. So the thing now that we need to do now, we need to now get our provider. And our provider is as easy as doing let provider be equal to new RPC. We have this RPC provider here. Then this RPC provider is provided by Starknet, the Starknet dependency. Then this RPC provider, it collects an object here. And first of all, we have the node URL. And I already have my URL here. So this is a public and free URL provided by Blast API for the Sepolia network. So it's Starknet Sepolia public.blastapi.io/rpc v0.6. So this is the provider that we are going to be making use of. The next thing we are going to be doing is we are going to be instantiating a new contract. So we are going to say let contract like this be equal to new contract. This contract is a variable that is also gotten from Starknet. Remember, getstarknet is only used for connecting and disconnecting your wallet. Any interaction with your contract is done by Starknet.js. So it's using Starknet.js. So our contract, remember we said the first thing our contract requires is what? Our ABI. So we have contract ABI. The next thing is the contract address. And the contract address is saved in this variable, contract address up here. So contract address. And the next thing is the provider. So this is the contract. So we're now going to get our count. So we have let count be equal to contract dot. So let's go into the ABI and see what's the name of that function. The name of that function is getBalance. Does get balance. To get balance like this. So we're going to await it. Await this. Then let's console log our response. That's count here like this. So After saving it, I've already, so when we click on the get count button, this function immediately gets fired off. So let's try it out. So connect our wallet, then get count. We can get our count without even connecting our wallet, because we're not making use of an account. We're making use of only the provider. So if we fire off this, we can see that our account is being outputted here, and it's outputted as 1. So that is the value of our account. But our account is coming as a big number. You can see 1N. So we need to convert this to a normal number. So the thing that we're going to do is we're going to convert it to a string. So console.log to string, counts.toString, like this. Then if we come, so if we try to get count again, you can see that 1 is outputted here. So this one now, we are going to set we have a state variable called count, and we are going to set that state variable to this new count that we have gotten. So we are going to set counts here. So we are setting counts to counts like this. Or let's call this data. Yeah? So we call this. Okay. No, it's not like that. So we're setting the counts to data here like this. So automatically now we've gotten our counts. So if you notice again, after getting our counts, you notice that the UI here changed. So you can see now we have our accounts, then we have these 2 buttons here. So this is done by conditional rendering in this app component, where if we do not have a count, that's when that first UI is being shown. That's this UI is being shown. But the moment that a count is gotten, this other UI shows with the buttons and the counts. So after connecting, we get our count. So we can see this here, right? So the next thing we are going to be doing is that for this particular contract only has a function to increase the balance. So to increase the balance, so that's what we are going to be doing. We're not going to be reducing the balance, we're going to be increasing the balance. So, and we can notice from this our ABI, we can see that in this increased balance, we can see that the name is called increased balance. We can see the type, and we know it's a function. Then we can see the inputs required for that particular function. And the only inputs required is a name. The name. So the inputs comes in an array of objects. In that object, each object has a name and type. So the name, one of the first inputs we need, first and only input we need is the amount, which is going to be a field 252, which is like a string in JavaScript. So that's the only input required for this particular function. And you can see.
Sorry, the type, is it a type for name?
A type for.
That type is obviously the type of the name, right?
Yes.
If we have multiple inputs, how would that be? Will it be name type, name?
Yeah, it will be name type.
Age type.
Yes, name type like this. So if we, so it's an array. Yeah?
Will it look like that?
Yes, it looks like, so assuming there's another, it's just be another object like this. So with a name and type here. So that's how it will be. So after this, so now we're going to be implementing the increase counter. So the first thing we are going to be using, so we're going to be initializing our contract again. So we are going to be using let contract be equal to new contract. Then we have the contract ABI, the contract address, and also, but now we're not making use of the provider, remember. We're going to be using of the account. And you know the account is being stored in state here, accounts, which is being set immediately after you connect your wallet. So we have an account here. So this is how it is.
So I have
Mm-hmm.
Instead of us to be doing manual, getting new instance of the contract, and now we're creating function that just gives us the instance of the contract every time, then we
Yes.
just use it. I thought it's a
Yeah.
very good thing.
Yeah.
So it's not
Okay. Normal, like, because it's just because this is a small project. Ideally, what we're supposed to do is we're supposed to put this in a state variable, preferably maybe making use of context API. Yes, which is also a React hook. So that is used for managing states. So we can just declare it in a context file, then it can be used wherever we need it.
Yeah,
So we,
but if we're doing that in case, it's going to be two because you have a situation where one is you just do a read contract and a
yeah,
write contract.
yes,
There are two different types of.
yes. So ideally, we're supposed to make use of like the context API for this type of thing. But because this is a small application, we're just doing everything in one file.
We can actually, you can still now like get contract utility function that because at the end of the day, we just want the instance of
Yeah.
like you play now.
Okay.
Just want that, that's what we need.
Yeah.
Calling the methods.
Mm.
Have that function.
Okay.
We just close that contract. You understand?
Yeah, I guess. Yes.
For
So.
decrease for
Mm.
decrease, just you have the instance of the function then perform the method.
Okay. So.
It's not like this contract doesn't do decrease.
Yeah.
There's no
So.
need to now.
Yeah.
Okay, it doesn't do decrease. It
Mm.
just get an increase.
So maybe in the future. Yeah. So maybe in a future version of this dapp, there will be an update to it. Then I can put that into consideration. So after we've initiated our new contract, we are going to now be calling that function. We are going to await it. Contract dot dot increase balance. Increase. Contract dot increase balance. I know it takes in one argument. So we are going to increase the balance by, let's say, 4. Let's say 4 like this. So this is everything. So let's check it out. So I'm coming. So let's on click increase content. So if you save this and we increase it, you can see that we need to sign it here. So if we click on confirm, so maybe we could have a alert here. You have increased the counter by yeah. So increase the counter by 4. I just see 4. So let me refresh this. Connect our wallet and it gets counts. I'm coming. Okay. I'm coming. Okay. So if we get our account. So our account is not being outputted. I'm coming. Mm. Mm. It's probably an internet error. So let's wait again. Yes, let me try that. It's coming up. Okay. Yeah. So we're supposed to set this to string. Data to string like this. So okay, so we can see that before our count was at 1, but we have increased it by 4. So you can see that our count is now 5. If we are to click this again, another error in operator. It's 56. I'll wait. So, okay. Okay, so it was probably a network issue. So if we sign this transaction again, then it was yeah. So you can see that it has been increased. So, but this is not ideal because we have to refresh the page to see the new count being reflected. So what we can just do is that inside this increase counter, we can now call that get counter again. Await get counter like this. Yeah. So this should work now. So if you refresh this and connect our wallet, then network is fluctuating. Connect our wallet and get our accounts. We can see our account is currently at 9. If we increase it, we need to sign the transaction. Then we confirm. Then nice. Okay.
Not supposed to set count. I'm not supposed to run set count.
Okay, immediately after it's increased. But we're not supposed to do that because it's supposed to be fetching directly from the contract. Yes. So us setting counts is like doing it's like cheating the system. So yeah. So basically, that's how everything is working now. We can connect our wallets, we can get counts, and we can also increase the counts by 4. Ideally, we are supposed to create an input field where we can type in the counts that we actually want to increase it by, then fetch it. But for now, we'll stick to increasing the counts by 4. So let me do a quick recap of everything so far. So first of all, we talked about how.
When we use it.
Okay, I have a question. Yeah. So for this particular contract, there's no implementation for a decrease. It's only increase. If I'll show you, but it's practically the same method. The only thing that you just change this function name here to decrease balance. That's basically the only difference. So everything that we've mentioned, we talked about how we make use of Starknet.js. Starknet.js is a library that helps us to interact with our smart contracts through our dapps. So Starknet.js enables us to be able to call our functions through our ABI. So we talked about the several components. We have the provider, which enables you to interact with Starknet without necessarily signing messages. That is when you're performing read calls. You can read states without signing messages, but you cannot alter or modify the contract state. That's what the provider does. And we have the signer. The signer API allows you to sign transactions and messages. Then the accounts, it extends the primary features of the provider API to include the signer API, which can be used to create and verify signatures. This API can make both read and write calls to the blockchain. So the account is basically your wallet address. So to perform read calls like the get counts, you only need a provider. You don't need an account. But when you want to write to perform write calls, that is to make changes to the blockchain state, you need to make use of an account which is coupled together with the signer, which is your wallet address. So then we talked about the contracts and the ABI. We said that the ABI is a JSON representation of your deployed smart contract, which exposes an interface for which other smart contracts can call functions within the smart contract. So, and we said that it's gotten from block explorers such as Voyager or StackScan, as we saw in this contract that we're making use of. Then we also talked about getstarknet, which enables developers to effortlessly build and connect their dapps to Starknet with Starknet.js. So getstarknet is used. So that's what getstarknet does. Enables us to connect our wallets to our dapps. Then we now went into the coding session where we were able to implement the different read and write functions of this particular contract in this UI. So that was basically all that we did. We learned how to connect, we learned how to read and write, and also to get our account. So I don't know if there's any questions that anybody wants to ask or anything you want me to clarify on.
So from what I see about the provider, right? If for instance, since the provider is only the provider to read from the contract,
Yes,
but the account does both read and write.
yes.
So you could see that the account can be used as an alternative in case that provider is not available.
Yes, but the problem with using only that, because the only problem with that is when you're using an account, you need to sign messages, which you're going to use gas fees to do that. So it's expensive to use an account when you can just use the provider for read calls.
So the question now is, if a provider is not available, let's say
Downtime.
so just use another provider, that's what you do.
Yeah, use on app because there are several. We can use Infura, there's Blast API, there's Nethermind, there's Alchemy. So we have several to choose from. So it's be hard for all of them to have downtime at the same time. We also have Juno. Yes. So I don't know. Does anybody have any question again? So, does anybody have any question or anything that you want me to clarify on? So, for those that joined online, thank you very much for joining. I hope you guys were able to understand. I don't know if you guys have any question. If you have any question, you can drop it in the chat box below.